If this video really helped you, then please help me too. Hello guys, I am a college student now and I suffered from an incident, so at present I can't paying my high college fees. So if you people can help me by donate some money to complete my study, then it will be a great help from you. Hello guys, welcome to our channel Mr. Curious Scientist YouTube. Today I will discuss on the topic computer science and engineering syllabus. In this video you will get every details and don't need to go anywhere. The topic mainly cover all subject details from 1 to 8 semester and subject topic and semester-wise marks distribution and also text and reference books. I will explain the syllabus in 4 different sections, for example topics and chapters and their marks distribution and topics detail-wise explanation and reference book. Now this CSE B.Tech course will be conducted in 4 years, and each year will have 2 semester. 1 now come first year first semester. Theory part Mathematics 1 Programming in C Physics Engineering Mechanics Basic Electrical Engineering. Practical part Programming Lab in C Physics Lab Basic Electrical Engineering Lab. Sessional Engineering Graphics. Now this subject marks distribution will be in 3 different ways, for example lecture given in the classrooms by the professor and notes, and theory part and the practical. 2 now come first year second semester. Theory part subject Mathematics, 2 Object-Oriented Programming Chemistry, Basic Electronics Professional Communication Environmental Science. Practical part Object-Oriented Programming Lab Chemistry Lab Basic Electronics Lab. Sessional Basic Manufacturing Systems Language Lab Extra Academic Activity. 3 now come second year third semester. Theory Discrete Mathematics Data Structures and Algorithms Web Technology Mathematics 3 Digital Electronics. Practical Data Structures Lab Web Technology Lab Digital Electronics Lab. 4 now come second year fourth semester. Theory part GN and Analysis of Algorithms. Computer Organization and Architecture Principle of Digital Communication. Mathematics IV Database Management Systems Institute Elective 1. Practical Design and Analysis of Algorithms Lab DBMS Lab Business Communication. 5 now come third year fifth semester. Theory Operating Systems Software Engineering Computer Networks Formal Languages and Automata Theory High Performance Computer Architecture Professional Ethics and Code of Conduct. Practical Operating Systems Laboratory Computer Networks Lab Tools and Techniques Lab. 6 now come third year sixth semester. Theory Computer Graphics Object-Oriented System Design Department Elective I Compiler Design Open Elective I. Practical Compiler Design Laboratory Computer Graphics Laboratory Advanced Programming Lab. Sessional Minor Project Cognitive Aptitude Test 2. 7 now come fourth year 7th semester. Theory Depth Elective 2 Depth Elective 3 Depth Elective IV Institute Elective 2 Open Elective 2 Legal Issues and Requirement in Engineering. Sessional Project, Part I, Practical Training. 8 now come 4th year 8th semester. Theory Open Elective 3 Depth Elective V. Sessional Project, Part 2 Seminar General Viva Voce. Next list of Institute Electives. Institute Elective I Engineering Economics International Economics Public Finance Institute Elective 2 Entrepreneurship Management Concepts and Practices Organizational Behavior Human Resource Management. Next come list of Department Electives. Department Elective I Parallel and Distributed Computing Distributed Operating System Service Oriented Architecture Formal Verification. Theory and Practice Distributed Database Systems, Software Design and Validation Big Data. Department Elective 2 Microprocessor Real-Time Systems Internet of Things Embedded System Mobile Computing. Department Elective 3 Software Testing Cloud Computing Software Project Management Information System Data Mining and Data Warehousing. Department Elective IVI Information Retrieval Natural Language Processing Human-Computer Interaction Computational Intelligence Artificial Intelligence Operation Research. Department Elective V Cyber Law and Intellectual Property Rights Computer Security Network Security Cyber Security. Next topic come Applied Sciences Physics. Oscillations and waves. Damped and forced oscillations. Resonance. Sharpness of resonance. Types of waves and wave equation. Interference of light. Analytical treatment of two-source interference. Distribution of energy. Newton's rings. Applications. Diffraction of light. Types of diffraction. Fraunhofer diffraction by single slit. Diffraction grating, determination of wavelength of light by grating. Laser and optical fiber, spontaneous and stimulated emission, population inversion, pumping, Ruby laser, applications. Principle of optical fiber as waveguide, types of optical fiber, acceptance angle, numerical aperture, applications. Electromagnetic theory, gradient, divergence and curl, Maxwell's equations in differential and integral form. Electromagnetic wave equation in free space, plane wave solutions, transverse nature of electromagnetic waves. Quantum mechanics, inadequacy of classical mechanics, de Broglie hypothesis for matter waves, phase velocity and group velocity, Heisenberg's uncertainty principle, wave function and its physical interpretation, Schrödinger's equations, particle in one-dimensional box, potential barrier, tunneling and applications. Thermodynamics, laws of thermodynamics, thermodynamic processes, variables, internal energy, enthalpy, entropy, Gibbs free energy, Maxwell's relations, TS diagram 73 mechanical properties of matter, stress, strain, Hooke's law, elastic constants and their relations, torsional pendulum, cantilever, stress-strain diagrams, crystallography, lattice, basis and crystal structure, unit cell, crystal systems, number of atoms per unit cell, coordination number, packing fraction for cubic lattice, lattice planes, Miller indices, relation between interplanar distance and Miller indices, X-ray diffraction and Bragg's law. Textbook 1. Engineering Physics, B.K. Pandey and S. Chaturvedi, Cengage Publication, New Delhi, 2013, 2. Concepts of Modern Physics, A. Beiser, Todd McGraw-Hill Publication, 2007. Reference Book 1. Engineering Physics, Gar and S. C. Gupta, Danpit Rai Publications, New Delhi, 2003, 2. Engineering Physics, Dutta R. Joshi, Todd McGraw-Hill Publication, 2010, 3. Quantum Mechanics, L.I. Schiff, Todd McGraw-Hill Publication, 2010, 4. Introduction to Solid-State Physics, C. Kittle, Wiley India PVT Limited 7 edition, 2007, 5. Elements of Properties of Matter, D.S. Mathur, 11th edition, S. Chand and Company, New Delhi. Next Chemistry, Chemical Bonding, MO Theory to explain bonding in homo and heteronuclear diatomic molecules, Band Theory, band diagrams for conductor, insulator, and semiconductors, bonding in complexes, VBT CFT, application of CFT in explaining magnetic moment and color of complexes, chemical equilibrium and thermodynamics, internal energy, enthalpy, entropy, and free energy, dependence of free energy on temperature and pressure, Gibbs-Helmholtz equation, conditions of spontaneity and equilibrium, equilibrium constants Kp and Kc, free energy change and equilibrium constants, Le Chatelier's principle and its applications to industrial syntheses, Van Hoff isotherm and Clapeyron-Clausius equation, partial molar properties, chemical potential, Gibbs-Duhem equation, 74. Electrochemistry, conductance, effect of concentration, ionic mobilities, Kohlrausch's law and application, transport number, determination by Hittorff's method, types of electrodes, electrode cell potential, Nernst equation and applications, to find electrode cell potential, equilibrium constant, solubility product and pH, modern batteries, fuel cells, AFCs, PEMFs, SOFCs, MCFCs, Zener battery, Li-ion battery, NiM-H battery, corrosion mechanism, of dry and wet corrosion, types of wet corrosion, prevention, chemical kinetics, rate of the reaction and rate laws of multi-step reactions, steady-state approximation, parallel, opposing and consecutive reactions, theory of reaction, collision theory, Lindemann's modification and absolute reaction theory, catalysis, types, theories, kinetics of enzyme catalysis, Micheli's Mitten mechanism, spectroscopy, UV-vis spectroscopy, Beer-Lambert's law, types of transition, concept of oxychrome and chromophore, factors affecting and Woodward-Fieser rules for calculation of endyene systems, IR spectroscopy, types of vibration, Hooke's law, detection of functional groups like CC, C equals C, O and H2 and C equals O. Textbook 1, Engineering Chemistry, Jane and Jane, 16th edition, Danpit Rai Publishing Company 2, Elementary Organic Spectroscopy, Y.R. Sharma, Revised Edition, 4th edition, S. Chand Group. Reference Book 1, Advanced in Organic Chemistry, Satya Prakash, G.D. Tooley, R.D. Madden, 2012, S. Chand Group 2, Principles of Physical Chemistry, B.R. Puri, L.R. Sharma, M.S. Pathania, 42 edition, 2007, Vishal Publishing Company 3, Elements of Physical Chemistry, Samuel Glasstone, 2nd edition, Macmillan 4, Spectrometric Identification of Organic Compounds, R.M. Silverstein, F.X. Webster, D. Kiemel, 7th edition, 2005, Wiley, Chapter 1005 Environmental Science CR2, Course Outcome. At the end of the course, the students will be able to CO1, understand different components and composition of environment and importance of EI. CO2, understand different air pollutants and their controlling measures, some important global phenomena. CO3, understand different water pollutants. sewage treatment, estimate different water quality parameters. CO4, understand different principles of green chemistry. R4M4 principle, cradle-to-grave approach. CO5, identify biochemical effects of toxic wastes, different steps in solid waste management. Prerequisite. Nil. Overview. Overview on environment, terminologies, components of Earth, lithosphere, atmosphere, and biosphere, concept of black body radiation, and albedo. Importance, scope and principles of IE. 75. Air pollution. Primary and secondary air pollutants, smog, oxidizing and reducing, important environmental issues, ozone layer depletion, acid rain, greenhouse effect, controlling measures, electrostatic precipitator, cyclone separator, catalytic converter, scrubbing, water pollution, types and sources of water pollutants, sewage treatment, primary, secondary and tertiary treatments, acid-base chemistry, pH and buffer, analysis of water quality parameters like dew, BOD, alkalinity, hardness, chloride, fluoride, UCPA and WHO guidelines for drinking water. Green chemistry, basic principles of green chemistry with examples, matrices to explain greenness, R to the power of 4 M to the power of 4 model with specific reference to ecnoburet, life cycle analysis, cradle-to-grave approach, waste management, classification of solid wastes, toxic and biochemical effects of solid wastes, heavy metals, biomedical and radioactive wastes, sources, and generation, management of solid wastes, collection, segregation, disposal. Textbook 1. Environmental Chemistry, AKDA. 7th edition, New Age International Publishers. Reference Book 1, Fundamentals of Environment and Ecology, DIDA, 2013 S. Chand Group 2. Engineering Chemistry, Jane and Jane, 16th edition, Danpit Rai Publishing Company 3. Environmental Science and Engineering, Aloka Debbie, 2nd edition, Universities Press 4. Textbook of Environmental Studies for Undergraduate Courses, Arach Baracha. 2nd edition, Universities Press 5. A Textbook of Environmental Studies, Sashi Chawla, 2012, McGraw-Hill. Next, Mathematics. Ordinary differential equations, basic concepts and definitions of one-order differential equations, formation of differential equations, solution of differential equations, variable separable, homogeneous, equations reducible to homogeneous form, exact differential equation, equations reducible to exact form, linear differential equation, equations reducible to linear form, Bernoulli's equation, orthogonal trajectories, applications of differential equations, linear differential equations of 2 and higher order, second-order linear homogeneous equations with constant coefficients, differential operators, solution of homogeneous equations, Euler-Cauchy equation, linear dependence and independence, Wronskian, solution of non-homogeneous equations, general solution, complementary function, particular integral, solution by variation of parameters, undetermined coefficients, higher order linear homogeneous equations, applications, differential calculus 2 and 3 variables, Taylor's theorem, maxima and minima, Lagrange's multipliers, matrices, determinants, linear system of equations, basic concepts of algebra of matrices, types of matrices, vector space, subspace, basis, and dimension, linear system of equations, consistency of linear systems, rank of matrix, Gauss elimination, inverse of a matrix by Gauss-Jordan method, linear dependence and independence, linear transformation, inverse transformation, applications of matrices, determinants, Kramer's rule, matrix eigenvalue problems, eigenvalues, eigenvectors, Cayley-Hamilton theorem, basis, complex matrices, quadratic form, Hermitian, skew-Hermitian forms, similar matrices, diagonalization of matrices, transformation of forms to principal axis, conic section, textbook 1. Krisigi, Advanced Engineering Mathematics, Wiley, 9 edition 2. Shanti Narayan and P.K. Middle, Differential Calculus S. Chand, reprint 2009. References Book 1. Graywall B.S., Higher Engineering Mathematics, Kana Publishers, 36 edition 2. Das H.K., Introduction to Engineering Mathematics, S. Chand and Company Limited, 11 edition 3. Ramana B.V., Higher Engineering Mathematics, TMH, 1st edition 4. J. Sinha Roy and S. Padhi, A Course on Ordinary and Partial Differential Equation, Kalyani Publication, 3rd edition. Next, Mathematics to Laplace Transforms. Laplace transform, inverse Laplace transform, linearity, transform of derivatives and integrals, unit step function, Dirac delta function, second shifting theorem, differentiation and integration of transforms, convolution, integral equation, application to solve differential and integral equations, systems of differential equations, series solution of differential equations, power series, radius of convergence, power series, method, Frobenius method, special functions, gamma function, beta function, Legendre's, and Bessel's equations, Legendre's function, Bessel's function, orthogonal functions, generating functions, Fourier series, integrals and transforms, periodic functions, even and odd functions, Fourier series, half-range expansion, Fourier integrals, Fourier sine and cosine transforms, Fourier transform, vector differential calculus, vector and scalar functions and fields, derivatives, gradient of a scalar field, directional derivative, divergence of a vector field, curl of a vector field, vector integral calculus, line integral, double integral, Green's theorem, surface integral, triple integral, divergence theorem for Gauss, Stokes theorem, textbook 1, Kriesige, Advanced Engineering Mathematics, Wiley, 9 edition, reference book 1, Graywall B.S., Higher Engineering Mathematics, Kana Publishers, 36 edition 2, Das H.K., Introduction to Engineering Mathematics, S. Chand, and Company Limited, 11 edition 3, Ramana B.V., Higher Engineering Mathematics, TMH, IST edition 4, J. Sinha Roy, and S. Padhi, A Course on Ordinary and Partial Differential Equation, Kalyani Publication, 3 edition, Mathematics 3, Partial Differential Equations, Basic Concepts, Solution of PDE by Variable Separable Method, Mathematical Modeling of One-Dimensional Wave Equation, and its Solution, Classification of PDE, and Transformation into its Normal Form, D'Alembert Solution of Wave Equation, Solution of One-Dimensional Heat Equation, Steady-State Flow of Heat in a Rectangular Bar, Solution of One-Dimensional Heat Equation by Fourier Integral, Solution of Two-Dimensional Wave Equation, Laplace Equation in Polar, Cylindrical and Spherical Coordinates and Applications, Solution of PDE by use of Laplace Transform, Complex Analysis, Complex Numbers and Functions, Basic Concept, Complex Functions, Derivatives, Analyticity, Cauchy-Riemann Equations, Exponential, Trigonometric, Hyperbolic, Logarithmic Functions, General Powers, Complex Integration, Line Integral of Independent Path, Cauchy's Integral Theorem, Cauchy's Integral Formula, Derivatives of Analytic Function, Taylor Series, Maclaurin Series, Laurent Series, Expansion of Functions, Singularities, Residues, Residue Integration Method, Evaluation of Real Integrals, Mapping, Conformal Mapping and Linear Fractional Transformation LFT, Textbook 1, Advanced Engineering Mathematics by Erwin Kriesig, Wiley, Incorporated, 9 edition, Reference Book 1, Higher Engineering Mathematics by B.V. Ramana, TMH, 2007, Mathematics IV Approximations and Errors, Approximation of Numbers by Truncation and Rounding Off, Types of Errors, Numerical Solution of Nonlinear Equations, Solutions by Bisection Method, Fixed Point Iteration Method, Newton-Raphson Method, Regula Falsi, and Secant Method, Rate of Convergence of Secant, and Newton-Raphson Method, Interpolation and Approximation, Finite Differences, Operators and Relation between them, Interpolation, Newton's Forward and Backward Difference Interpolation, Newton's Divided Difference Interpolation, and Lagrange Interpolation, Approximation of Functions by Best Fit Straight Line, Quadratic, and Exponential Curves using Least Square Method, Numerical Differentiation and Integration, Numerical Differentiation of 1 and 2 order using Difference Table, Trapezoidal Rule, Simpson's 1/3 and 3/8 rules, Gauss-Legendre's 2 points and 3 points formulae, Error in Numerical Integration, Numerical Solution to ODE, Taylor Series Method, Euler's Method, Modified Euler's Method, Runge-Kutta methods of order 2 and 4, Reduction of 2-order ODE to first-order ODE and its solution by Arquet method of order 4, Solution of System of Linear Equations, LU Factorization Kraut, Doolittle and Cholesky, Solutions by Gauss-Seidel and Gauss-Jacobi methods, Largest Eigenvalue and Corresponding Eigenvector by Power Method, Probability Theory, Introduction to Probability, Random Variables and Probability Distributions, Mean and Variance of Probability Distributions, Mathematical Expectation, Moments and Moment Generating Function, Binomial and Poisson Distributions, Normal Distribution. 80. Textbook 1. Advanced Engineering Mathematics by Erwin Kriesig, Wiley, Incorporated, 9 edition. Reference Book 1. Higher Engineering Mathematics by B.V. Ramana, TMH, 2007. 2. Higher Engineering Mathematics by B.S. Graywall, Kana Publisher, 36 edition 3. Numerical Methods for Scientific and Engineering Computation by Jane, I. Imger and Jane, New Age International, P. Limited. 6th edition 4. Numerical Methods by Arumugam, Thangapandi and Somasundaram. Sidech Publishers, 2 edition. Discrete mathematical structure. Logic. Proposition, truth values, connectives, logical equivalence of composite statement using truth table and without truth table, predicates and quantifiers, rules of inference, methods of induction. Set, relation and function. Set, operations on set, principles of inclusion and exclusion, relation, types of relations, properties on binary relation, equivalence relation, partial ordering relation, Hasse diagram, lattice, definition of function, injection, bijection, surjection, permutation function. 81. Boolean algebra, lattices and algebraic system, principles of duality law, basic properties, Boolean function, and Boolean expressions, DNF and CNF, recurrence relation and their solutions, discrete numeric function and their manipulation, generating function, concept of recurrence relation with constant coefficients, solution of recurrence relation, direct method and by using generating function, graph theory, basic terminology, types of graphs, group code, isomorphic test, adjacency and incident matrix, paths, circuit, shortest path algorithms, Dijkstra, tree, rooted tree, binary tree, spanning tree, cut set, MSD algorithms, prim, and Kruskal, planar graph, groups and rings, concept of binary operations, algebraic structures, semigroup, monad, group, abelian group with examples, properties of groups, cyclic groups, and its generator, subgroup, normal subgroup, cosets, Lagrange's theorem, homomorphism and isomorphism, ring, field, integral domain definition with examples, textbook, 1, Discrete Mathematical Structure, PHI by Kalman, Busby, and Ross. Reference Book 1, Elements of Discrete Mathematics, a Computer-Oriented Approach by C. L. Liu, D.P. Mahapatra Tata McGraw-Hill 4th edition 2013, 2. Discrete Mathematics, and Its Applications by Kenneth H. Rosen, Tata McGraw-Hill 4th edition. Numerical Methods, Approximations and Errors. Approximation of numbers by truncation and rounding off, types of errors. 82. Numerical solution of nonlinear equations. Solutions by bisection method, fixed point iteration method, Newton-Raphson method, regular-Falsy, and secant method. Rate of convergence of secant and Newton-Raphson method, interpolation and approximation, finite differences, operators and relation between them. Interpolation, Newton's forward and backward difference interpolation, Newton's divided difference interpolation, and Lagrange interpolation. Numerical differentiation and integration, numerical differentiation of 1 and 2 order using difference table. Trapezoidal rule, Simpson's 1/3 and 3/8 rules, Gauss-Legendre's 2 points and 3 points formulae. Error in numerical integration, numerical solution to O. Taylor series method, Euler's method, modified Euler's method, Runge-Kutta methods of order 2 and 4, reduction of 2-order ode to first-order ode and its solution by RK method of order 4, solution of system of linear equations, solutions by Gauss-Seidel and Gauss-Jacobi methods, numerical solution to PD, types of partial differential equations, finite difference approximations of derivatives, numerical solution of Laplace equation by 5-point formula, numerical solution of parabolic equations by Schmidt method and Crank-Nicolson method, probability theory, introduction to probability, random variables and probability distributions, mean and variance of probability distributions, mathematical expectation, moments and moment generating function, binomial and Poisson distributions, normal distribution. Textbook 1, Advanced Engineering Mathematics by Irwin Krestig, Wiley, 9th edition. Reference Book 1, Higher Engineering Mathematics by B. V. Ramana, TMH, 2007. 2. Higher Engineering Mathematics by B. S. Graywall, Kana Publisher, 36 edition 3. Numerical Methods for Scientific and Engineering Computation by Jane, Iyengar, and Jane, New Age International, P. Limited, 6 Edict Ion 4. Numerical Methods by Arumugam, Thangapandi, and Somasundaram, Sidech Publishers, 2 edition. Next subject come Humanities. Now I will explain in short, you can pause the video and read it. Professional Communication Engineering, Economics, International Economics, Professional Ethics, and Code of Conduct, Human Resource Management, Entrepreneurship, Law of Contracts, and Law of Torts, Intellectual Property Law. Now next come to our main topic, computer science and engineering, programming in C, introduction to computer and programming, basic concepts of computer organization, CPU, memory, I/O devices, number systems, evolution of programming languages, structured programming, compilation process, source code, object code, executable code, operating systems, interpreters, linkers, loaders, algorithms, flow charts, pseudocode, program constructs, character set, identifiers, keywords, data types, constant and variables, operators, precedence and associativity, expressions, statements, input and output functions, control structures, branching and looping, functions, library and user-defined functions, formal and actual parameters, function prototypes, parameter passing, call by value, call by reference, recursion, storage classes, arrays and strings, one-dimensional array, multi-dimensional array and their applications, string manipulation, pointers, pointer variable, pointer arithmetic, passing parameters by reference, pointer to pointer, pointers to functions, dynamic memory allocation, structures, unions, pointer to structure and pointer to union, linked list, file handling, declaration of file pointer, opening and closing files, working with text and binary files, additional features, command line arguments, bitwise operators, enumerated data types, typecasting, macros, preprocessor directives, data structures and algorithms, introduction structures and unions, pointers, dynamic memory allocation, algorithm specification, space and time complexity arrays, abstract data type, dynamically allocated arrays, polynomials, two-dimensional array, address calculation, matrix addition and multiplication, sparse matrix linked list, singly linked lists and chains, representing chains and C, polynomials, sparse matrix, doubly linked lists, circular and header linked lists, stacks and queues, stacks using dynamic arrays and linked list, queue using linked list, circular queues using dynamic arrays, evaluation of expressions, priority queue, DQ trees, introduction, binary trees, binary tree traversals, threaded binary trees, binary search trees, AVL trees, M-way search trees, B trees, B+ trees, tree operation, forests, graphs, the graph ADT, graph representation, graph operation DFS, BFS sorting, inertian, sort, quick sort, merge sort, heap sort, bubble sort, selection sort, radix sort. 173. Searching, linear search, binary search, static hashing, dynamic hashing, database management systems. Introduction, general introduction to database systems, database, DBMS definition, approaches to building a database, data models, 3 schema architecture of a database, challenges in building a DBMS, various components of a DBMS, relational data model, concept of relations and its characteristics, scheme instance, integrity constraints, ER model, conceptual data modeling, motivation, entities, entity types, various types of attributes, relationships, relationship types, ER diagram notation, extended ER model, converting the database specification in ER, and extended ER notation to the relational schema, data storage and indexes, file organizations, primary, secondary index structures, hash-based indexing, dynamic hashing techniques, multi-level indexes, B-trees, relational query language, relational algebra operators, selection, projection, cross-product, various types of joins, division, example queries, tuple relation calculus, domain relational calculus, introduction to SQL, data definition in SQL, table, key, and foreign key definitions, data manipulation in SQL, nested queries, notion of aggregation, PLSQL. 174. Relational database design, dependencies and normal forms, importance of a good schema design, problems encountered with bad schema designs, motivation for normal forms, dependency theory, functional dependencies, Armstrong's axioms for FDs, closure of a set of FDs, minimal covers, definitions of 1NF, 2NF, 3NF, and BCNF, decompositions and desirable properties of them, algorithms for 3NF and BCNF normalization, multivalue dependencies, and 4NF, join dependencies, and definition of 5NF, transaction processing, concepts of transaction processing, ACID properties, concurrency control, locking-based protocols, recovery and logging methods, computer organization and architecture, basic structure of computers, computer types, functional units, basic operational concepts, bus structures, machine instructions and programs, memory location and addressing mechanism, memory operations, IA32 register structure, IA32 addressing modes, IA32 instructions, machine instruction format, IA32 assembly language, program flow control, logic, and shift rotate instructions, subroutines for IA32, programming examples, basic processing unit, some fundamental concepts, execution of a complete instruction, single and multiple bus organization, hardwired control, microprogram control unit, 175, arithmetic, design of fast adders, multiplication of positive numbers, signed operand multiplication, fast multiplication, integer division, floating point numbers and operations, memory system, basic concepts, semiconductor RAM memories, read-only memories, speed, size, and cost, memory module design, cache memories mapping functions, replacement algorithms, memory interleaving, memory performance considerations virtual memories, input-output organization, basic input and output operations, accessing IO devices, interrupts, interrupt hardware, enabling and disabling interrupts, handling multiple devices, controlling device requests, exceptions, direct memory access, interface circuits, standard I/O interfaces PCI bus, SCSI bus, USB, FLINS classification, RISC versus CISC, textbook, 1. Computer Organization, Karl Hamaker, Zvonko Vernezik, Safwat Zaki, 5th edition, TMH, 2002. Reference book, 1. Computer Organization and Architecture, William Stallings, 7th edition, PHI, 2006. CS 2008 Design and Analysis of Algorithms CR4, Course Outcome. At the end of the course, the students will be able to CO1. Use different computational models, order notation, and various complexity measures e.g., running time, disk space, to analyze the complexity performance of different algorithms. CO2. Describe, apply and analyze the complexity of certain divide and conquer, greedy, and dynamic programming algorithms. CO3. Understand the techniques used for designing fundamental graph theory algorithms, and apply them to solve other related problems. CO4. Identify and analyze criteria and specifications appropriate to new problems, and choose the appropriate algorithmic design technique for their solution. CO5. Understand the classes P, NP, and NP-complete, and be able to prove that a certain problem is NP-complete. Prerequisite. Data structure and algorithms, CS 2001. Introduction. Algorithm design paradigms motivation, concept of algorithmic efficiency, runtime analysis of algorithms, asymptotic notations, divide and conquer, structure of divide and conquer algorithms, Maxman problem, binary search, quick sort, randomized quick sort, merge sort, analysis of divide and conquer, runtime recurrence relations. 176. Greedy method, overview of the greedy paradigm, knapsack problem, optimal storage on tapes, job sequencing with deadlines, activity selection problem, minimum cost spanning tree, single source shortest path, Huffman's code, dynamic programming, overview difference between dynamic programming and divide and conquer, applications, 0/1 knapsack, shortest path and graph, matrix chain multiplication, traveling salesman problem, longest common subsequence, graph searching and traversal, overview, traversal methods, depth first and breadth first search, backtracking, overview, 8-queen problem, sum of subset, and knapsack problem, Brock and bound, LC searching bounding FIFO branch and bound, LC branch and bound application, 0/1 knapsack problem, traveling salesman problem, computational complexity, complexity measures, polynomial versus non-polynomial time complexity, NP-hard and NP-complete classes, examples, approximation algorithm for traveling salesperson problem, compiler design introduction to compiler, phases of compilation, grouping of phases, lexical analysis, role of lexical analyzer, input buffering, specification of tokens, finite state machines and regular expressions and their applications to lexical analysis, syntax analysis, context-free grammars, top-down parsing, backtracking, LL1, recursive descent parsing, predictive parsing, bottom-up parsing, shift-reduce parsing, LR and LALR parsing, error recovery and parsing, handling ambiguous grammar, semantic analysis, intermediate forms of source programs, abstract syntax tree, polish notation, and 3 address codes, attributed grammars, syntax-directed translation, conversion of popular programming languages language constructs into intermediate code forms, type checker, symbol tables, symbol table format, organization for block structures languages, hashing, tree structures representation of scope information, code optimization, consideration for optimization, scope of optimization, local optimization, loop optimization, frequency reduction, folding, DAG representation, data flow analysis, flow graph, data flow equation, global optimization, redundant sub-expression elimination, induction variable elements, live variable analysis, copy propagation, object code generation, object code forms, machine-dependent code optimization, register allocation, and assignment generic code generation algorithms, DAG for register allocation. Now I will explain in short. You can pause the video and read it. Formal languages and automata theory, computer graphics, operating systems, parallel and distributed computing, distributed database systems, computational intelligence, principle of automata theory, service-oriented architecture, data structures using C, computer organization, relational database management system, introduction to computer graphics, distributed operating systems, microprocessors, software testing, pattern recognition. If this video really helped you, then please help me too. Hello guys, I am a college student now and I suffered from an incident, so at present I can't paying my high college fees. So if you people can help me by donate some money to complete my study, then it will be a great help from you. Thank you for watching our videos. To get more videos like that, please subscribe our channel and like and share.